Okay, so today we will start with the new unit on our course website. And in textbook, it's probably chapter 13, okay. Last unit is in chapter 11. So this unit, you can find the material in chapter 13, but of course, I always have some of my own stuff here, okay? So let's take a look. So chapter 13, before move on, chapter 11 basically discuss inheritance and polymorphism. Okay, and there is another concept involved with that chapter is dynamic binding. Okay, and so for the polymorphism, we know that you can assign super type variable, is it? You can assign subtype object to supertype variable, is it? And the dynamic binding then is, it calls some method. So that might normally override in subclass, is it? So then that method will not come from supertype, it will come from subtype, okay? So we call it dynamic binding. And inheritance is a subclass inherited the attributes and behaviors, certain, not often, depends on if it's, so it can only inherit protected and public, not apply to private, okay? So it can inherit protected and public features, attributes and behaviors. This is basically instance variables and methods. And but keep that in mind, okay? Constructor cannot be overridden, okay? Override. Is it so? Subclass need to have its own, and but it involves call superclass constructor first. Okay, so that's just a brief overview regarding inheritance and polymorphism. The key points that we discussed. Chapter 13 discusses a more broader concept. So we will learn concept of abstract class and interface. Okay, so let's take a look first. The example we are going to start is on our course website. You can find the example. It's called Chapter 13, Example 2, Employee. Okay, regarding, and in one package it has 6 files. Okay, we have employee, then we have commission employee, and the base plus, and hourly, and the salary, and the driver. Okay, we have 6 files. So let's take a look here. First, I need to remove, close some of the, otherwise to get messed up. So let's first take a look at this employee class. For this employee class, if you take a look at public class, it's exactly the same as what we previously learned. Is it nothing new? But over here, we have a new keyword called abstract ahead of the class keyword, is it? So if you have this keyword abstract, then that means this class is an abstract class. Okay, so the difference between, so all of the class so far we have learned. We have learned they are called concrete class. So today a new concept is called abstract class. So concrete class, they can be used to create instance, or we call it object. So basically you can do new class. Is it called the constructor? Okay, for abstract class, it cannot be instantiated. So that means it cannot be created with an object. Then you may ask why then do because class guy you want to use it to create an object. Is it that's because for abstract class, even though you cannot use it to create an object, so no new, but it still allows inheritance. Is it? So you can still group of the common attributes for certain category of objects together and put them to an abstract class, serve as superclass. Is it? And then you can create subclass from an abstract superclass. That's allowed. Okay, that's allowed. But over here, there is another question. So if you recall in Java, what class is a root class? Who still remember?
Object class.
Yes, very good. So object class is a root class. So, but to be careful, okay, object class is a concrete class. So you can use object class to create an object. Okay, it's a concrete class. But we also said in Java, all class are subclass of object. Is it? So this employee basically is also subclass of object. But object is concrete. This is abstract. Is that fine? That's also fine. Okay, so you can create a subclass from a concrete superclass. You can also create a concrete subclass from a super abstract class. Okay, so either way it's fine. Okay, the major difference between concrete class and the abstract class is not used to create object. So always keep this in mind. Okay. Then let's see in this example, okay, employee first name, last name. So it's common, still private, nothing new. And then we have the constructor. This is pretty straightforward. We have set and get for each of the instance method. So nothing new here, is it? And okay, and here we said we have the annotation for override. And this override who?
The object to string method.
Yeah, very good, super good. So it's object classes. Okay, so object class has a default to string. If we don't override it, we cannot get customized output for our object. Is it? So, and basically over there, it's just tell you some of the kind of where it is relation, where it is information, okay, not the description of your object. Normally for toString, what we want you to have the description of this object. Okay, anyway, so over here, this toString, we just had a description of employee. So you want to name, first name, last name, social security, and here you do the formatted for the string. So formatted use percentage, so S represent string. Okay, then this percentage does the matching for each one of it. And then the next one, oh, I messed up here. The first one matches this employee. The second matches the get first name. This one matches this. And the next percentage matches this. And the last one matches this. So in formatting for the string, the percentage, you can also do D. Then that means integer. So suppose I have the last one as percentage D, then you can do like, suppose over here you have integer I equals 10, then you can do I. Okay, then that percentage D is going to match I. Okay, so anyway, so that's for the formatting of the string. Okay, and here, take a close look of this method. It's a little bit of weird from what we have already learned. It has a keyword called abstract, and it has a return type and the name of the method. But be careful, this method has a key difference from other example. Other method is there is no implementation. So this method, we call it an abstract method. So it just gave you a name. There is no implementation. It's called as it. So the implementation will leave it to subclass who inherit this abstract class to implement it. It just gave you, because over here, this employee earnings, because for employee earnings, for the calculation is different. Is it between salaried, commission-based, and hourly? It's all different calculations. So that's why over here, it doesn't provide you any of the calculation. Then you may ask, then why do you need to have this? It's unnecessary. Yes, it is necessary. Because why? Because earnings is one of a key features. Is it for an employee? You do need to provide this. So that's why here it's just provide a kind of stake holding, is it? But as to how to implement, that depends on if it's salaried employee or hourly employee or commission employee, something. Okay. Okay, so this is a general concept about abstract class. Okay, we kind of already see. Then next, let's see the commission employee. Okay, so for this commission employee, then if you take a look, it says extends employee. But be careful, okay, employee is abstract class. And this commission, if you take, there is no abstract. So it is concrete class. And it is concrete class, that means you can use it to create objects. Okay, for employee, you cannot. Okay, and this is constructor, pretty straightforward. In the very first, it's still called superclasses constructor. Okay, and then you may say, oh, abstract class that has a constructor, but you don't use it, you don't call new that, yes, because it's needed to initialize the variables of the instance variables, is it? Okay, and then this two just set the gross sales and commission rate. This is instance variable, okay, of the class itself. And you can call set, get, set, and get method, nothing new, is it? And also over here to override. This override who override employees, overrides superclass, is it? And it also call employees to string, okay? This is employees, employee, the abstract superclasses. Okay, and then let's take a look over here. So this time for commission employee, you have the earnings method. It override, is it? This override who override employee. This is abstract method. Is it? So this method is implemented. Okay, it's calculated the earning. Okay, so this is commission employee. Then let's see if hourly employee. Okay, for our hourly employee, same thing. It's inherited from employee class, is it? And it also has its own instance variable. So for its constructor, it's just called superclass. It's constructor first. And then it's set up its own weight and hours instance variable. That is set method, get method, set, get, nothing new, is it? And its own toString, same thing, it's called superclasses. And over here, it also calculated its own earnings. So we can clearly see, is it? So if we draw the UML diagram, so here is employee, is it? And from this employee, we inherited, we create a commission employee. Is it? And then now we have this hourly employee. Is it? And so you have one abstract superclass, you can have multiple concrete subclass, and each of it has its own implementation, is it? So they implement their own version of earnings method. Earnings method, okay. So this is hourly, pretty straightforward. Then let's see salaried. So salaried employee also inherited from employee. It just has a single instance variable, weekly salary. Same thing for its construct, it's called the superclasses. And then it has the set method, the get method, is it? Nothing new. It also has a toString, is it? And it also has get payment amount, okay. And so this is salaried employee. And let's take a look, the last one. Did I pick the wrong one, I believe? Hold on, okay. The salaried employee. I think I picked the wrong one. Hold on. Because it's supposed to, hold on. Yes, this is a correct version. Okay. Sorry. Let's take a look at the correct version of salary employee. They extend from employee and constructor set get and the toString is nothing new. And over here, it also override the earnings, override who employees. Again, that employees abstract earnings method. So it does implement it. So in this case, so we have employee class, but this time we have three different subclasses. It hourly, employee, commission, employee, and here we have a salary employee. And then we have, and so from one abstract superclass, is that we create three concrete class. Okay, so that's the inheritance relationship. And then next, let's see the base plus. This time it extends from commission employee. So commission employee is employee subclass. Is it? So now from this, we create base plus commission employee. Is it? So you can create a multiple level of inheritance. Okay. And for its constructor, it's called super. So this super is whose? Is commission employees. Super class, okay. And then it also has set method, get method as usual, toString, is it? And over here to call super data toString. So this super is whose? Is commission employee. Okay, and here it also has its own earnings. So this override who? Override commission employee. Okay, be careful. Not employees' earnings. Okay, so be careful. This earnings override commission employee. Okay, that's all these classes. Then let's take a look at the driver part. So for the driver part, if you take a look, we create a salaried employee. You can directly do new, is it? Because this is a concrete class. So you can create object from concrete class. Okay, so hourly, commission employee, base plus commission employee. So all four of them are okay, is it? And then over here, it call their respective earnings. Okay, so over here it will call their respective ones. Okay, then next, let's see. So here, this employees is what? It's an array of employee type. Okay, and here we do new employee square bracket form. And previously we said employee is abstract class. So that means there is no new associated with it. But why over here this new is legal? Why it is legal here?
Because it's making an array, not an object.
Yes, very, very good. Okay, this new, very good. This new is regarding array, has nothing to do with object, employee object. Okay, it's still object, but it's not employee. This is regarding array. okay, regarding array. So keep this in mind, okay. And then, so suppose I do something here, employee sub-0 equals new employee. Suppose their first name, last name, social security. Will this be fine then? Can I do this? Can I do this?
No.
Yes, this is a no. Okay. Why? Because what? Abstract class. Okay, doesn't allow to create object. Okay, so that's a no. Okay, that's a no. And so the type of array is an abstract class. So abstract class can be used for data type. Data type. So that is fine, is it? And then you remember salary employee, hourly employee, all these are objects. Is it object? And you assign this object to array elements, employees. So will this be legal?
Yeah,
Yes, this is legal. Why? This is sub type. This is what? Super type. You can assign subtype to super type. Is it? This is fine. Okay, this is allowed because of inheritance relationship. Is it? It is a relationship. Because salary employee, of course, it's an employee. Is it type? So that is fine. It is allowed. Okay, you can always assign a subtype to a supertype. And so if you have a subtype variable, and here is supertype object, then what do we need to do? Then you need to cast it first. Okay, you need to explicitly cast it first. Okay, so that is fine. That's part of the benefits for superclass, is it inheritance? Because you see over here, then you can just declare array, is it? And group all of various kind of employee to this employee array, is it? Then you can use it to do a for each loop. For each loop, is it? And for each loop, the variable type is employee. Is it? Is employee. Because that's very beneficial. Just assuming like you design some website. Let's say you design a website and you have different type. Is the website display first name, last name, social security number? Is it? And it can take a different type of employee. Is it? Then you see you can just kind of declare an employee array and then do the loop one by one. Is it so that you don't need it for each specific one, then you define a different data type. That's not efficient for the management when you design software. So here it shows its advantage that then I can loop this array. And when you do the print line, system data print line, you can directly plug in an object. So an object of its type. And why you can do this? Because basically this is equivalent to you call current employee .toString. Okay, basically it's equivalent to you call that toString. Okay, so here is a question. This toString is whose toString? Then is employees. Is it employees? Anyone knows the answer here? Because it's basically it's equivalent to you call current employee .toString. Okay, it's just we skip writing the toString, but it's equivalent to you call. Okay, that's why you can directly put a type of object to the print line. Otherwise, it won't allow you, because suppose print line only take number value and a string is a character. Those data type it shouldn't accept other type unless you have the toString. But of course, object class has the toString, so that's why you can just directly write something like this. Okay, so this toString is whose? Employees, objects, or anyone else? So anyone knows this answer? This is related to what we discussed in the previous two class, I believe. Anyone knows the answer?
Whichever employee that you're calling.
Yes, very good. It depends on whatever the employee is. It is a salaried employee or hourly employee or commission employee or base plus employee, is it? So it's going to be the specific ones. Specific ones. And what do we call that? There is a term, because when you do job interview, someone may ask you what that term is.
Polymorphism.
No, this is not. When you invoke the toString.
Oh, dynamic binding.
Yes, dynamic binding. Yeah, you are also kind of, you can see, but in this sense, it isn't, because this is not polymorphism. This is dynamic binding, because the print line, the parameter, is not object type. It's some string value, integer value or double value, those related. Okay. Okay, so this is dynamic binding. Okay. And then we can also, if you recall last class, we learned the instance of to check, is it if some object belongs to some class, is it? If it is belongs to some class, then we can do what? You can cast it, is it, to a subclass. variable, is it? And after you cast it to subclass variable, then you can call the subclass's respective method, is it? Because this is from the subclass, this is from subclass, is it? Then you can directly call, okay? But over here, you do need this casting, okay? You do need to. And this is over here, you need to cut because this set base get base just from the class itself, okay? If you don't do casting, then that the compiler will not think it's correct, okay? And over here to call current employee the earnings. So this earnings will be from whose? From employee. So same question, or from object, oh, object doesn't have, or from subclass of employee. So the earnings is from whose? Employees' earnings. Does employees' earnings implemented? It's not. Is it? Employees' earning is abstract method. And if it is abstract, but it's not implemented, nothing output, how can you do formatted output? That shouldn't work. It shouldn't work. But why over here it's working? That's because what? So once again, here we do dynamic binding. Is it because it's called base plus class, base plus commission employee, or commission employee, or salary employee, or hourly employee, call their respective earnings method, the implemented earnings method. Is it? That's why over here, this is fine, okay? And this printf is a formatted output, okay? And formatted output, this is for floating data, is it? And here is a formatting, is it? It's after the decimal point, it takes 2 decimal points, okay? So that's what it represented. Also take the every 1,000, okay, the comma. Okay, and then what next one is try to show is it will also loop through individual element of that array, employee array, is it? And try to get the class, the name, okay? And we can run this program and take a look at the result. And for the result, those numbers are pretty from the programs calculated. But for the last part, we can clearly see, is it? Even though the array type is employee, but for each element of it, it's their own class, is it? Their own class, corresponding one, is it? And over here, it also gives the package name, is it? And here is the class name. So the respective class, is it? Yes. Okay, so that's the first example we already discussed is regarding the concrete, the abstract class and the concrete class. Okay, and the next let's go ahead talk the next idea, new concept. The next one should be Okay, what the next one, new concept we discuss is interface. Interface, okay. So we will take a look at this example where 1, 2, 3, we have 5 Java file, okay. We still have that employee.java, okay, salary employee, but we have 2 other ones, invoice and payable, okay. And if you take a look, it looks like, you see, payable and invoice sounds like nothing to do with employee regarding the inheritance, is it? And so what's going on here? Okay, so let's take a look. So first take a look at the payable. And the payable here, if you take a look for our definition, we have a keyword called interface. Okay, so this is not a class, it's an interface. Okay, it's an interface. So generally speaking, a class, it has what? Instance variable. Then it also have instance method. Is it? But previously we also learned it also has class variable and class method. Is it? And so those related with that keyword static. And for instance variable and instance no static. Is it? An instance variable and instance class, they need objects to access. Is it to access? For class, where class method, they don't need any objects to access. Okay, so that's regarding class, okay? And we also learned today abstract class. Is it? Abstract class, so concrete class versus abstract class. And abstract class, we learned the purpose is to be used for superclass. Is it for inheritance? Okay. Oh, regarding abstract, I forgot one more point. So abstract class, it has the example we learned. It has abstract method. Okay, but this is not mandatory. Abstract must have abstract method. No. Okay, so abstract class can also just have like instance method. Instance methods and the static methods. Okay, it doesn't mean that it must have one abstract. There is no such rule. Okay. Okay, then what is interface? Interface, generally speaking, the focus it put more is regarding the behaviors. Okay, so regarding some interface that it can provide. Interface is provide something for other people to use. Is it? So generally speaking, it's used to group certain type of methods together. So that's its focusing point. Okay, not like class. Class, it's used to represent certain group of objects. objects. Okay, so then what's the difference? What's the difference? So let's just think about it. Is it like a person? So person is very general, is it? So, and from person you can create employee, is it? And you can also create some other type of person, is it maybe like a student, something, is it? So anyway, so all, no matter employee, still they belong to this person group, this type of objects, is it? But just think about animal. Is it? The animal is another group of object, is it? Then you can have mammal. Is it? You can also have like a reptile, something like that. Is it different? But let's think about what animal and the person share some same kind of action. Then animal can eat, and the person also eat. Is it? Animal can run, and the person can also run. Is it? But of course, animals eating style and the person's eating style, human beings, definitely different. Is it? Run also different. Is it? So here regarding interface is, okay, can we just group like all eating related behavior, the actions together, and group them together, is it? So then this, and also provide, also group all kinds of running behaviors together and give it some name. Then this is called interface. Okay, interface. And then this interface, animal can use it, person can also use it, is it? And even robot can also use it, is it? It's just some behaviors. Okay, so that's what interface concept is. Okay. Okay, then regarding this interface, specific interface, we call it payable. Payable, then by the name, it's regarding payment. It's regarding payment. So then you need to provide some method. It's called get payment. Is it to get payment? And the return some double. Is it? Here, once again, if you take a look, this method is not implemented. Okay, so in interface, this method by default, basically it's equivalent to you define as public and abstract. So it is abstract method. And it's also public visibility. Okay, so always keep in mind, even though you didn't write public and abstract, it is still public and abstract. Okay, and let's take a look at this one. So this is a variable, okay, and then you also assign value. So in interface also allows you to define constant variables, constant values. Okay, constant values by default is also public and static and final. Okay, so it's static means, generally speaking, you don't need instance, is it? So this is just the interface, so static. And the final means you cannot change it, as it means constant. So you can also define constant values for interface. So here we define like this K, okay, as a static final, so basically a constant public constant value, okay, for this payable interface. Okay, so we run out of time today, so we will continue our discussion on